Hi guys, so in this particular video I'm going to talk about solutions to some of the multi-threading problems given in Leetcode, and the multi-threading problems on Leetcode can be found in this problems tab in the concurrency section. I mean, a lot of people have been demanding me to make some videos on multi-threading, so here are some of them. So let's see. I mean, I'll try to solve 4 or 5 questions in this particular video. So let's start with the first question, which is problem 1114, print in order. It's an easy problem. So the question is simple, that you are given a class. Its interface is like this, that the class name is foo. It has 3 methods, first, second and third. All these 3 methods, I mean, the implementation of all these 3 methods is same. They are calling this print method only. The only difference is that they are passing different argument values. Like first method passes the string literal first, second method passes the string literal second, and third method passes the string literal third. Now these 3 methods will be running in 3 different threads. So the same instance of foo will be passed to these 3 different threads. Let's say those 3 different threads are ABC, are labeled as ABC. So thread A will run for method first, thread B will run method second, and thread C will run method third. Now based on how operating system schedules these 3 different threads, I mean, any thread might be scheduled first on the core, right? Maybe the second thread B is scheduled first, then maybe the thread B is scheduled first, then thread C, then thread A, right? Or any kind of ordering can be there. Maybe thread A, then thread C, then thread B, and all these 3 threads can be scheduled together as well if, let's say, these 3 threads are pinned on different cores. Now your target is that irrespective of whatever order these 3 threads are scheduled, and irrespective which method starts running first, the output should always be same. Like you should always print first, then second, then third. Basically we have to make sure that this first method runs first, then the second method, then the third method. Okay, so output should always come out to be first, second, third. Now how can we solve this? So it's a simple thread synchronization problem. I mean, I had discussed this kind of problem yesterday as well in one of my multi-threading video. So this is same as only. So we are going to solve this in C++, preferably in C++ 17. So this is the interface which they have given, like class foo. It has 3 methods, first, second and third, and all of these 3 methods are calling this method, like print first, print second, print third. So this line of code will remain as it is. I mean, you don't have to touch it, as Leetcode has mentioned here. All these methods are doing is that they are printing the string literal. This method will print string literal first, this method will print string literal second, and similarly this method will print string literal third. So how can we solve it? Like we have to make sure that this first runs first, then second, and then third, and all these 3 methods are running on different threads. So it is a simple problem. I mean, it's kind of a thread synchronization problem if you see it. Like they are, let's say, 3 threads, T1, T2 and T3, right? We just need to make sure that first T1 should run, and when it is finished running, then only thread T2 should run. When it is finished running, then only thread T3 should start running, right? So let's say if we have this let's denote the turn, like whose turn it is now to run, by this turn variable. Okay, so we can set the turn initially as 1, and what thread T1 will do is that it will immediately start running, and then when it is finished running, it will set the turn as 2, that now it is the turn of the thread T2 to run. What thread T2's implementation would look like is that it will keep on spinning. Okay, I mean, it will keep on checking that while this turn not is equal to 2, it won't do anything, and when this turn becomes 2, it will basically print second, and after that it will set the turn as turn of the next thread, that is thread T3. And the implementation of thread T3 will also be same only. I mean, the only difference is that it would be checking while turn not is equal to 3. So this is how you can actually do it. That and if I visually show you, so it is, I mean, this kind of concept or this kind of thread synchronization principles are usually used while we are building high throughput pipeline applications. I mean, where like this whatever is the output of thread 1 is actually the input to this thread 2. Okay, and similarly whatever is the output of thread 2 is the input to thread 3, and so on. So this is kind of a pipeline, right? Because if you imagine these 3 threads as pipes which are connected together, so whatever is input from here, let's say if water is flowing from here, so output of this thread T1, I mean, whatever water flows out of thread T1 will be, this pipe P1 will be the input to whatever this pipe 2, right, or thread 2. Similarly, whatever is the output here will be output to 30. I mean, you can think of this as a pipeline system, because even n pipes are connected together, so whatever is the output of pipe n-1 is the input of pipe n, right? And to make sure, so in these pipeline architectures, like we have to make sure that this thread 2 waits until this thread 1 is finished. Similarly, this thread 3 waits until this thread 2 is finished. So for that, we can use that spinning architecture. Okay, so this is how I have implemented it. Like this foo class which they had given, it has a atomic integer variable that is mturn, which denotes whose turn it is now to run. So this is atomic because it will be accessed by multiple threads, and we want to make sure that there is no data race, because more than one thread might be concurrently writing or reading it, right? So we want to make sure that there is no data races. And initially it is initialized as 1, and then the first method, it does nothing, it just print first, and it sets the turn of the next thread. So we are calling the store method of this atomic class, and we are passing it the value 2. Now this memory order, you can ignore it for now, but I've done this or used this for maximum efficiency. And I mean, I'm not going to explain memory order in this video. There are a lot of good research papers on it, so you can read about it from there. But it does not matter if you provide memory order or not. I have just done it for efficiency purposes. But if you would have just done this mturn.store 2, so it would have also worked. Or just if you have done this as well, mturn is equal to 2, then it would have worked as well. But just for efficiency purposes, I am passing the memory order as well. Now what does this print second method do? It keeps on spinning until the turn has become 2. So I have implemented this spin lock method, which takes an integer argument turn, and it keeps on spinning. Basically this while loop, we will be stuck in while loop until the value of this mturn has become 2 equal to this turn. Okay, and here I am using the load API of the std atomic, and I am passing it the memory order acquire. Again, this memory order is not mandatory. I've used it for efficiency purposes. You could have directly done this as well. I mean, this is also a valid syntax. Or you could have done this as well, that m_turn.load not is equal to turn. Okay, but we want as much efficiency as possible with atomics, so that's why I'm using this. So when it would become, I mean, when the turn of thread 2 will be there, so when this mturn has become 2, we will print second, and then we will set the turn of the next thread, which is 3. Similarly, thread 3 is also spinning until the turn has become 3, and eventually when the turn becomes 3, it will print third. So this is how you can solve it. So I have already, I mean, submitted my solution here, and my submissions are here, so it has been accepted. So this was the first question. Again, you could have implemented is using mutex locks or mutex or semaphores as well, but I think using std atomic is usually efficient. I mean, it's not always efficient, we have to benchmark it, but it is usually efficient because this is like lock free program, and lock free programs are usually efficient. But it also depends on a lot of things on your architecture, and I mean, it depends on a lot of things. So, and other thing is that I also wanted to teach this concept of spin locking. I mean, this spin locking concept is very, very useful, and it can be applied in a wide range of problems. So let's see next problem. So next problem is also simple, like basically it is problem 1115, and here again you are given a class interface. The class name is foobar. There are two methods, foo and bar. Both of these methods do nothing, but they basically print, I mean, foo method will print foo for n times, and bar method will also print print bar for n times. Okay, now the thing is that both of these methods are running in two different threads. So here they have written that the same instance of foo bar will be passed to two different threads. Thread A will call foo and thread B will call bar. Now your basically your target is that you should print the string foo bar n times. Now if you notice that this method foo only prints foo and this method bar only prints bar, so you have to make sure that first foo is printed, then bar is printed, then again foo is printed, then bar is printed, then again foo is printed, then bar is printed. Like this should happen for n times, right? Due to thread interleaving or the way these two threads are scheduled, these things should not get mixed up, right? I mean, it should never be the case that foo is printed, then again foo is printed, or maybe bar is printed first, then foo is printed, right? So here this problem can again be solved using the concept we used in the previous question. So here I have the code ready for it. So this is your foo bar class. It is basically having, I mean, we are passing to its constructor, we are passing this value n, that is how many times we have to print foo bar. Now this is the foo method. So if you see here that we are running this for n times. Now if we compare the method to the foo method which they had provided. So their method, all it does is this, it is running this loop for n times and it is calling this print foo method, which will do nothing but just print foo. So what is the code which I have added? So my approach here would be that, again, like there are two threads, right? Thread A, like let's say thread T1 and thread T2. So I want to make sure this thread T1 is running foo method and this thread T2 is running bar method. So what my target is that first thread T1 should run, then T2 should run, then again T1 should run, then again T2 should run, because then only we will get this output, foo, then bar, then again foo, then bar, right? So I have to follow this ordering. So this is again similar to our previous problem only. I mean, whatever is first thread T1 should finish running, then thread T2 should start. Then when thread T2 is done, it should set the turn that now it's time, or it's the turn of thread T1 to run. Then when thread T1 is finished, it should set the turn as that now it is the turn of thread T2 to run, right? So for this I have done this. I have taken this can print foo variable, which is an atomic boolean variable. So what I am doing here, that both of these methods will be spinning, and this is our spin lock. It does nothing, it just checks that whatever flag we are passing, it will keep on spinning in this while loop, or it would be stuck, this method would be stuck in this while loop until the value of this can print foo has become equal to this flag. Okay, so basically can print foo indicates that if this is true, then we can print foo. If this is false, then we should print bar. Okay, so here I am spinning. So when in foo method, whenever we are spinning, we are passing the value true, because we can only print this foo when the value of this is true, right? Because this can print foo equal to true indicates that now you can print foo. So initial value, it is initialized as true only because we first want to print foo. So it's simple. We spin in the log, whenever the value has become true, we print foo, and then we set that, okay, now it's time for the bar to be printed. So I'm setting this as false. What bar method would look like, it would do the opposite. Like it would keep on spinning until the value of this particular can print foo flag has become false. When this is false, it means it's time to print bar. We have printed bar, now it's time to print foo again. So we set the value of this can print foo to true again. Okay, so this is how these two methods would look like. And again, here I am using these memory orders for maximum efficiency purposes. And yeah, I think I did a mistake here. This should be actually release memory order. Yeah, so this is how this will look like. And if we submit this code and run it, it would easily pass all the test cases. Let's submit it. And as you saw, like we solved this problem again using the concepts of spin lock only. So it is accepted. So spin lock is a very powerful technique. Again, this can be solved using different ways as well. You can use semaphores, you can use mutexes, but my target is to actually teach spin lock using these problems. So let's see the other problem now. Other problem number 1116 is print 0 even odd. So here what you have to do is that you have a function print number. So this print number function is nothing. Whenever you pass an argument to this, it accepts an integer argument, and whatever is the argument passed to it, it will print that number. Okay, so now you are given this 0 even odd class, and it has three methods. First method is named as 0, second method is named as even, and third method is named as odd. Now all these three methods will be running in three different threads. So thread A will run 0, thread B will run 0 even, and thread C will run method odd. So now your target is that the constructor of this 0 even odd will actually accept a integer n. So this is that till how much basically till what point you have to print the numbers. Now your target is that you will be printing numbers from 1 to n, but the way you have to print this is that you first print 0, then you print 1, then you print 0 again, then you print 2, then you print 0 again, then you print 3, then you print 0 again, then you print 4. This will go on until the number n has been printed. Now, as you might have guessed, like this 0 will be printed by the 0 method. This whatever an odd number will be printed by the odd method, and an even number will be printed by even method. Okay, so basically this 0 will be printed by this 0, then this 1 would be printed by this odd method, then this 0 will again be printed by this 0 method, this 2 will be printed by this even method, then 0 will again be printed by 0 method, then there is 3 which will be printed by this odd method, then 0 again, then 4 would be printed by this even method, and so on until we have reached n. Now all these three methods are running in three different threads, so based on how these threads are scheduled by the operating system, the output might vary, but we have to make sure that the output also always comes in order. I mean 1 to n numbers should come in order only, and like they are separated by 0. So this is again a thread synchronization problem only, that you have three threads and first thread A should run, then thread C should run, then thread A again, then thread B, then A again, then C, then A again, then B, right? Because this is the way we are printing numbers, like 0, then odd number, then 0, then even number, then 0, then odd number again, then 0, then even, right? So let's see how we can solve this. So this is can also be again solved using atomics. I mean, atomics are a very powerful thing in C++. I mean, if you become good with them, good and comfortable with the usage of these, you can implement a lot of solutions related to multi-threading. So what I have done here is that we have an integer variable called current number, which would indicate that what number we have to print, and then we have this atomic integer. Now this is atomic because it will be accessed by many different threads concurrently, so we want to make sure that there is no data race. Again, you could prevent race conditions using mutexes, but or locks or semaphores, but I mean atomics, it's just atomics are sometimes very, you can say, efficient, because these are lock free. I mean, the way the hardware instruction is generated for it on certain architectures, I mean the machine code which is usually generated for atomic read and writes are usually efficient, but it depends on hardware to hardware and also other things. So yeah, so here I have this 0 print state method, and it is an atomic, and then we have this enum, okay, 0 print state. So what does this enum indicates is that it indicates the state of the printing of 0. So if you look at this question, so, I mean the output which is to be required, so you can see that like printing of 0 basically has 4 states. Like first state is that if the state is that print 0 before odd number, then you have to print 0. Then after that, the state of 0 would become that, okay, 0 has been printed after odd number, so now odd number can be printed. Now when this odd number is printed, next turn is to now print an even number, but before printing an even number, we again want to print 0, right? So you can regard it as third state, like print 0 before an even number. Then when that 0 is printed, the state would now become that 0 has been printed before an even number. Now we are good to print even number. Now when that even number is printed, it's time to print an odd number, the next odd number. But before that, we have to print a 0. So state has again become that print 0 before odd number. Now when we have printed this 0, now the next state becomes that, okay, 0 has been printed before the odd number. We can now print the odd number, right? So this is how I have actually implemented the solution based on these states. So I have this enum which has 4 states, like print 0 before odd number, so it means we have to now print 0, and this is the 0 which will appear before the odd number. Now when that 0 has been printed, the state would become that, okay, 0 has been printed before that odd number. Now we are good to print the odd number itself. The next state is that before printing an even number, like we have to print another 0. So this state indicates that now we have to print a 0 before even number. When we have printed it 0, now our state has become that 0 has been printed before even number. Now we are good to print that even number. Then again our state would become, then again, like next odd number has to be printed. So before that we have to print a 0. So again the state has become that we have to print 0 before odd number. When that 0 is printed, we are good to print that odd number. So state becomes that 0 has been printed before odd number. Now let's print the odd number, and like this will keep on going. So this is the way I have ensured thread synchronization here. Like if we look at let's look at the odd method first. So all it is doing is that we will spin in a while loop until this current number is less than equal to n. So n is the number till which we have to do the print the numbers from 1 to n, and this current number indicates what is the current number we are printing. So if this is less than equal to n, we first check what is the state of the 0. Okay, I mean an even number should only be printed when the state of the 0 has become that 0 has been printed before even, right? So if the state of this 0 is that 0 has been printed before odd number, this is like an odd number, so we need to check that 0 has been printed before odd number. If it has been printed, if it has not been printed, we do nothing. Like we will continue and we will again check. If it has been printed, now it's time to print this number. So first we check that if current number is, if it has become greater than n, we have to break. So you might be wondering why we are doing this check again. Like we already had checked here. Now why do we want to do this check? We want to do this check because if you see, this condition will only break when this even method has executed. So when this even method would execute, it would actually increment the current number because next odd number has to be printed, right? So that's why between this check and this check, the current number might have been incremented. So that's why we have to check this again here. And when, if this is less than equal to n, we print the current number. We also increment the current number, and now we set the state of the 0 as that odd number has been printed. Now it's time to print the next even number, but before that we have to print a 0. So that's why the state would be print 0 before even, right? And similar is the implementation of this even method. So we check until the current number less than equal to n. We check what is the state of the 0. I mean, even number should only be printed when the state of 0 has become that 0 has printed before even. If the state is not equal to 0 printed before even, we continue. If the state is that 0 has been printed before even, it's time to print this even number. So we first check that if current number has become greater than n or not. If it has become greater than n, we break. Otherwise we print the number. We also increment this current number, and we set the state of the 0 as that even number has been printed. Now it's time to print the next odd number, but before that odd number we need to print a 0. So state is print 0 before odd. Similarly, what is the implementation of this 0? I mean, we will continue in the while loop while current number less than equal to n. We fetch the state of the 0. Now 0 should only be printed when the state of is one of these, like either we have to print 0 before odd or we have to print 0 before even. If that is not the state, we continue. Otherwise we will try to print 0. We first check that if current number has become greater than n, then we break. Otherwise we'll print 0. And now it's time to set the new state. So new state, what would be the new state? If the current state was that you had to print 0 before an odd number, so new state would become that 0 has been printed before odd number, so that this odd method can now print the next odd number, right? Otherwise the state would become that 0 has been printed before even number now, so that this even method can print the even number, and we'll set the state. So you can see like these two methods are working in conjunction. I mean, this even method, this condition will only become true when 0 has been printed before even, because this state will only be changed when 0 has been printed before even, right? So when 0 has been printed before even, the state would be changed to this. Similarly, this odd method also, this condition only becomes true when 0 has been printed before this odd number, and this basically this new state is updated. So this is how these three methods, I mean, this is how we have ensured synchronization here. So I had already submitted this on Leetcode, and all the test cases were passing fine. Here is the submission. So there is no data race in it, and I think it is also very efficient program. Next up, this problem 1195, FizzBuzz multithreaded. It's a simple problem. Again, it's similar to the previous problem that you have a class FizzBuzz. It has 4 methods: fizz, buzz, FizzBuzz, and number. So all these, the responsibility of these 4 methods are that this method will print fizz, this method will print buzz, this method will print FizzBuzz, and this method will print whatever is the number x. Okay. Now all these methods are running in 4 different threads. I mean, these 4 methods will be running in 4 different threads. Again, thread A will run fizz, B will run buzz, C will run FizzBuzz, D will run number. Now your output is that so I mean, if you look here, the constructor of this FizzBuzz class is actually accepting a number n. So you have to basically iterate all the numbers from 1 to n, and for each number I, where I is like greater than equal to 1 and less than equal to n, you are supposed to print some output. So the output should be this, that if the number I is divisible by 3 and 5, you should print FizzBuzz. If the number I is divisible by 3 and not 5, you should print fizz. If number I is divisible by 5 and not 3, you should print buzz. And if I is neither divisible by 3 nor by 5, you should print the number I itself. And all the numbers should be printed in order, I mean from 1 to n only. So here is a sample output, like since we start iterating from 1 to n, and like 1 is not divisible by 3 or 5, so we printed the number I itself. Similarly, 2 is not divisible by 3 and 5, so we printed the number I itself, that is 2. Then 3, I has become 3, I is divisible by 3 but not by 5, so in that case we print fizz. Similarly, now it has become 4, neither divisible by 4, 3 nor 5, we print the number 4. Now it has become I is 5, which is divisible by 5, not by 3, so hence we have printed buzz. Similarly, so again a thread synchronization problem, because 4 threads running concurrently, but there is an ordering on the output, or the you can say ordering on the way they should be executed, right? So let's see how we can solve this. So the way I have solved this is that I have made this current number an atomic integer. So this current number is going to indicate, basically this is going to indicate that what is the I, and how should that I be handled, whether we should print the number I itself, or we should print fizz buzz or fizz buzz. And now each method has been implemented like this, like let's look at the method fizz. So we will be running an infinite loop for all the 4 methods, because we have to run until all the numbers from 1 to n has been handled. We check what is the current number. Okay, so we get the current number. If current number has become greater than this n, it means we have to break, right? Otherwise, we check if current number is divisible by 3 and not by 5, we'll print fizz, and we will set the current number as the next number, right? Current number plus 1. And similarly is the implementation of buzz and fizz buzz and number. I mean, here also we are checking, all these 4 methods are running in infinite loop. Everywhere we check if current number is, for buzz we are checking if current number is divisible by 5 and not divisible by 3. In that case we print buzz, otherwise we store the, and when buzz has been printed, we update the current number as current number plus 1. So this is like that pipeline architecture only, right? You do your work and now you set the state so that or the turn of the next thread, right? So here the turn is determined by the next number itself, because based on whatever is the state of the next number, these conditions, like whether that number is divisible by 3 and not by 5, or divisible by 5 and not by 3, or divisible by both 3 and 5, or neither divisible by 3 nor by 5, will determine whose turn it is to run now. Okay, so in this case that condition is this, I mean the turn, whose turn it is to now run is determined by this condition, and the next turn is updated. Like we have to, when a thread has run, it also needs to set that whose turn it is now to run, or whose is the next turn. So that turn is set by this, by incrementing the current number. And there is no data race in this program, because this is the only shared variable current number, which is you can say accessed by all different threads concurrently. I mean, read write accesses are being done, and this is atomic, so there is no data race as well. So this is all I had. I mean, there is one more question, the dining philosophers, but I will cover it later. And I think that's all I had for this particular video. Thank you guys for watching. Please do not forget to like, subscribe and comment, and I'll see you all next time.